Welcome to watch this video safe and agile transportation of cable-suspended payload via multiple aerial robots. In this video, we would like to introduce several real-world experiments and simulations. To the best of our knowledge, this is the first experiment to achieve the transportation of a payload with maximum agility of the Multiple Aerial Robots Transportation System, MARTS, by pushing the aerial robot's thrust to its limit. And the first work to achieve real-time trajectory generation for safe and agile aerial transportation via MARTS in complex environments. The MARTS passes through the consecutive S-shaped turns smoothly, without colliding with any obstacle. Our planning scheme can ensure safety when crossing a narrow gap by adjusting the configuration of MARTS. In this emergent replanning experiment, we select F as the new target while the MARTS is flying towards E. Within the limited safe distance away from the obstacle, the MARTS successfully perform a large maneuver to bypass the obstacle. Besides, a consecutive replanning experiment is conducted. These experiments validate the safety, dynamical feasibility, and agility of the planned trajectories, as well as the responsiveness of our planning scheme. We further integrate a MARTS containing 5 aerial robots and deploy an agile transportation experiment. This experiment validates the scalability of our scheme with respect to the number of aerial robots. The MARTS can estimate the payload's mass by stabilizing at a predefined hovering position for a while. For the 5 different payloads, the estimation errors are no more than 4.2%. For this type of trajectory with 3 circles, its centripetal acceleration as well as the agility can be increased by reducing the trajectory's duration. For each of the 2 weights, the maximum instantaneous average motor's RPM of any aerial robot in the MARTS along the trajectories approaches the limit of what the battery voltage can tolerate, i.e. 24,000 RPM. This experiment validates that our control scheme can hold the maximum agility of the MARTS. Besides, we compare the root mean squares errors RMSE of 3 non-mass point payloads using trajectories planned respectively by accurate and inaccurate masses of the payload. And further deploy an agile transportation experiment for the MARTS under the wind disturbance. These experiments validate the robustness of our control scheme against the uncertainties on the payload and the wind disturbances. We design a simulation to verify that when any aerial robot in the MARTS fails, our planning scheme can replan a new trajectory for the MARTS composed of the remaining aerial robots that guarantees a continuous transition of states, provided that the failed aerial robot has the ability to automatically detach itself from the MARTS. We design ablation experiments to verify the necessity of the maximum RPM constraint to ensure the dynamical feasibility of the trajectory. And reveal the importance of improving the accuracy of the planned RPMs by introducing the torque caused by the cable that cannot be strictly tethered to the aerial robot's center of mass into the derivation of flatness maps. We also conduct another ablation study to validate the necessity of the cable's vectorial constraints enforced in our planning scheme, which helps avoid the local optima. We benchmark our planning scheme with a state-of-the-art work. Compared to WABA's method, our planning scheme reduces the time consumption of trajectory optimization by 2 orders of magnitude. As the density of obstacles increases, the success rate of WABA's method significantly decreases, whereas our planning scheme maintains a high success rate. It can be seen that the trajectory planned by our method can fully utilize the space to deform the trajectory so that the MARTS goes around the obstacle in a silky smooth manner, unlike the trajectory planned by the WABA's method, which is always close to the edge of the obstacle. This video introduces our real-world experiments and simulations, validates the effectiveness of our planner and control schemes, and demonstrates their great application value. Thank you for watching.